Hi, my name is Ben, and I would like to present our work on disentangling domain-specific and domain-invariant factors of visual domains. In unsupervised image-to-image translation, we assume that there exist two distributions of images, cats and dogs in this example, and that there is a single ground truth cross-domain mapping f that maps between them. Our goal is to recover this unknown function f using only unpaired examples from respective distributions. We assume that this ground truth mapping preserves as much information as possible, including the fur color, pose, etc. Unfortunately, if we look closer at most real datasets, like male and female faces from Celebi in this example, we will notice that males have variable amount of facial hair, whereas females have none, rendering the one-to-one alignment problem not very well defined, since it is not clear whether a model should generate a beard for a given female input. One way to resolve this ambiguity is to alter the problem definition and map pairs of images into the target domain, using guide male images to specify male-specific factors, facial hair in this instance. The resulting unsupervised many-to-many alignment problem is well defined. To solve this problem efficiently, a model needs to first learn which factors are shared and which are domain-specific from data, because this split can vary from one dataset pair to another, and then learn how to combine shared factors of source images with target-specific factors of guide images. In this work, we present RIFT, the first method to actually infer which factors are domain-specific from data. The core observation in the heart of our method is that if you map a male image to the female domain and try to reconstruct the male image back, you should be able to reconstruct the pose and the background of the original because they are varied in both domains, but you should not be able to recover whether the original male image had a mustache because female images have no corresponding degree of variability to encode this information. We evaluated prior work in our new method across 3 splits of 3D shape dataset with different domain-specific and shared factors to measure how well it can infer which factors are specific to each domain from data, a synthetic action dataset, and a particular split of Celebi dataset. It worked almost perfectly across all 3 splits of 3D shapes, whereas all prior methods failed to a various degree. On SynAction, which matches the inductive bias of Adain methods, our method performed on par with Targan v2. And on Celebi, all methods preserve all the overall pose well, but only RIFT and DID correctly preserve the background color of each image, since it is varied in both datasets and therefore should be preserved, and applied hair color and facial hair of the guide in corresponding domains. We evaluated quantitatively as well across all 3 datasets. Our method performed best on average and was best or second best with a small margin across all 3 datasets, whereas all other methods performed poorly on at least one of 3 datasets. So the main takeaway is that in this paper we propose RIFT, the first method that can reliably infer which factors are domain-specific and which are shared from unpaired examples from 2 distributions without any additional supervision. Thank you very much for your attention. Please come and check out our poster.